Hey, my name is Brett, and I want to show you a project that I've been working on for on and off the last 4 or 5 years. This is my animatronic Bender, everyone's favorite robot. Right now, you can see he is in clock mode because the main purpose of this project is to be a wall clock. And what I intend to do for the final version is do either a 3D print like this one with a metallic coating similar to the Mandalorian. Maybe I'm going to weather it, and this will look like a found artifact that we kind of collecting dust and is acting as a clock in the background. Or maybe I will do a mold casting for the once I get a good 3D print, and you can do some cool aluminum powders and stuff in that mold. You can see the electronics here right now. A little bit of a flicker. This is the first prototype version of the electronics, and mostly off-the-shelf parts from Adafruit, and this really cool black acrylic, so it doesn't allow light to come in except for in almost like an egg crate grid direction. So with the LCD pressed right up to the front of it, we get a cool view. You can see I haven't finished the mouth or some of the other components, and you can see where I ran out of space on my 3D printer. This is actually a visor that's inset, and the whole construction is meant to go on the wall. So again, supporting that clock idea. So what we can do is pop this out from the rear, and oh, there we go. There's one of the animations that plays every couple of seconds. The Bender eyes. And in the rear, I fit all of the electronics right now. In the future, they'll probably go a few other places, and just the display components will remain here. So we have a friction fit retaining ring that's kind of holding this whole assembly in place. And we have the black acrylic and a couple of the, let's see, there's four Adafruit backpacks with 8x16 LED rows, and you can see the colon there for when we do the time. And this is all mounted to kind of a motherboard setup. So I have each of the individual components are trying to do a different thing. We have a real-time clock module that's going to keep very accurate time. I have a power supply. This is the audio module. So this will trigger all the fun sounds loaded onto it. And then we have the brain here that's running all the controls plus the display right now. And I'll talk a little bit more about the electronics in a minute. But you can see we just wired all that up to fit in here and have a working prototype that proves the animation, the scale. So this is almost kind of to human scale here, which I think is a good size for a clock. It kind of makes sense for the display resolution, etc. So that's the prototype that I went with, and I built that maybe 5 or so years ago. It was a pretty cool project, and that's about as far as I got with it. Wrote all the Arduino code to kind of lay out a matrix of what LEDs should be on and when, and it just got really complicated to solve all these particular problems. What do I do for the mouth? Do I have a higher resolution display for the mouth? How do I get those analog waveforms? So what I want to do is kind of show you what I've built already and how I arrived there, and what my plans are to actually finish this project, because recently I saw a animatronic Bender from one of my favorite YouTube creators, and they did a really good job with the eyes and the servos, and creating those same animations that I'm going for with this digital non-mechanical version. And again, that I think finally I can take this project across the finish line. So let me see if I can show some relevant details here. So a quick look at the 3D model here. Let's see, probably just open up Fusion. So this is the visor, for example, and it has a lip on the inside, so all the components can drop into and sort of rear load, and that was printed face down. So then you get a nice flat facing Bender. Here's some of my original notes, actually. Let's take a look at those. So just kind of sketching out some of the ideas of, what faces I might want to have Bender have, how the PCB boards might be laid out or wired here. Yeah, okay, so this is kind of that stack where we have the frame and the acrylic and motherboard with kind of the daughter boards for the individual components and how they might be laid out. I looked at, how might I even construct this, and 3D printing seemed like the obvious choice. Yeah, here's the original design. I don't know if I have this file anymore, but again, you can see how all those pieces load into there. We create a spacer ring if we need to. And here's some block level diagrams. Again, we have, in this one, I think I was using a M4, yeah, Feather M4, and little audio board. This is very popular for the soundboard for lightsabers and other animatronics and props. And they're connected to these 4 boards over I²C. And again, there's kind of the logical diagram of how I hooked everything up. And I started looking at a number of other ways that I could maybe project light to create the waveforms for the mouth. Some of the other ideas for grids or LED patterns or zones. And I kind of landed somewhere over here where, okay, let's do a grid for the eyes, and then let's do a slightly different grid for the mouth that would allow us to blank out these rows and columns to create those. And I went with, let's take a look at one more picture here. So this is the design that I'm going with for the overall Bender. Right, we have the antenna that's going to be a probably RGB LED at the top, so it can go red if he gets an email, or green, if he's searching for something. We have the eye components, and this will be its own microcontroller and its own display LEDs. We'll have another microcontroller for the brain that will coordinate all these activities, accept input, save settings, all that kind of thing. We have the real-time clock module that gives us very accurate time, which is great. We're going to have to do some power distribution because of all the LEDs. The mouth LEDs will probably be some sort of curved array of LEDs or something else pretty cool. And then we have the audio board with the speakers, probably some down-firing speakers to get the audio clips out there. So what did I do next? I went with a couple different ideas. I threw together this guy over here, which is a simulator, I guess I'll call it. And the purpose of this simulator is to do all the heavy lifting, and then I can export the code that this simulator generates. And again, I got the idea by looking at the software, is it Maestro software, that was being used in the Bender animatronic. And I realized, okay, I want to create all these animations. I need a tool to create them, and then however I arrange my LEDs and whatever that exact timing is, I can define later and have this code export the very simplified LED blinking code. So play a angry face. So in this case, I have a grid of LEDs. I think they're 16 tall and let's see, 16 wide for each of the eyes, and then another couple extra rows for the center column. So if we want to do a scrolling display message, or we want to do the colon for clock, we can light those ones up. And I had to look at, like, how would I approach this as, I'm a software developer by trade. So this is unique steps. So we have, in this case, 3 steps that we want to animate to get to our angry face. And we can take the Bender simulator here. We can move the eyes around. We can move the upper lid up and down a little bit higher, or change the angle of that lid, which is pretty cool. Let's reset some of these. So now, maybe he's bored, or maybe he's surprised. So we can go and lock that in, and we can add additional steps to this. And then later we can change the timing of those steps, or add another step in between if we want that transition to be a little bit slower or faster. So this lets us sort of define what those eyes are doing. And then these are some of the the ones that I've created. Okay, we have bored, shocked. He's just going to open his eyes a little bit. We've got a blink. And I also defined it as it goes in one direction, if it just reverses to get the exact same equal and opposite reaction, then we're just going to play that in reverse. So no need to think too hard about the reverse animation. And then there's also some custom cases where maybe we want to look quickly to the right and then slowly back to center. And so I built all that, built the, we can turn the antenna on, right? And we can also do a few things with the mouth. So with the mouth, again, what I want to do is turn off these segments in order to animate the mouth. So let's play one for you here. So we have kind of an O face where he's opening mostly the center of his mouth. And we have kind of a blah, blah, blah here where it's more horizontal in the lines of the mouth. And then a little fun one here, he's going wow, or he's whistling, or ooh. So we take all those, and what I did to actually build this was build a geometric version and then sort of down-res that into the pixel grid. So after we create all these individual expressions, angry, bored, shocked, etc., what we really want to do is we want to create a performance. So a performance is a series of expressions, both for the eyes, the mouth, and the antenna, and it's overlaid with the audio timing. So you can see we have a pretty cool timeline thing here, kind of like a video editor. And so I can grab one of these expressions that I built on the other screen, for example, bored, and maybe it starts in just one frame. Okay, so it's going to start at frame number 1. It's going to take 5 frames to sort of build up to that final expression. It's going to hold for 1 frame, and then it's going to reverse for 5 frames. We have kind of our curve, right? Again, very video editing centric. This is kind of what I'm familiar with. And again, we can ease in and out, and we can duplicate or delete this as needed. So again, I can shift the timing. Let's say if I want this to start a second sooner or a second later, I can shift that around. What does this look like when we play it?
I'm a bender. I bend girders. That's all I'm programmed to do. I went to bending college. I majored in bending.
All right, so hopefully that came out in the recording.
I'm a bender. I bend girders. That's all I'm programmed to do.
But the point here is I can spend all day building and tweaking a very specific animation and linking it to the audio clip, and then export one complete set of instructions in terms of what the mouth and eye LEDs need to do in an exact timing, and synchronize that with the playing of predefined audio clips. So I have a number of, let's see, add an audio clip here. So I have a number of predefined audio clips I found on some Bender soundboards on the internet. So this is what I want to build. I think you can imagine that as the virtual tool here for building this Bender, and the very realistic animations that I think I'll be able to do that here. I started with a foam cutout in the garage here, which was great. And I think I have one interesting reference image here. Where is it? Oh yeah. So I don't remember where I saw this, maybe DeviantArt or something, but yeah, we have the Bender clock, which is pretty cool. So that is what I'm trying to build here. And I still need a little bit of help in terms of, maybe my mouth design is the incorrect one. I'm building a couple prototype boards. I have one over here. Let's take a look at it. Okay, one more prototype to show. So this prototype is, so I'm calling the larger version here, the full-size version, Bending Unit 22, of course. And so this is Bending Unit 11, which is a small-scale model. And I'm using a very standard 7-segment LCD display. We have the same real-time clock. We have the same processor and an array of buttons. So, I said, what if I made a small desktop clock that would allow me to prove some of the more complicated parts of the design that wasn't the display? So let me plug this in and we'll see a boot up sequence. Grab the diffuser. So you can see Bender's looking left and right, and he's getting kind of bored, so the visor comes down, and now it's just a clock. So in this clock module here, we have like a menu button. We can go through and we can do different modes. So we have a play mode here where we can choose, this is the board expression. And let's see, we can set the time, or we can just look at the clock. So let's go to the play mode and let's play that board expression. Okay, the visor comes halfway down. He's bored. And we can move through the menu. This is, I believe, look left. Oh no, this is he's winking his winking left. This is look left, where he's going to shift his eyes to the left and back to center. So the point of this one is not that these animations look particularly great. The point is that we have animations in a relatively low resolution screen, and we have different modes. So really interesting to start to get into a state machine and be able to control Bender with just a couple of buttons here and say, okay, well, it's in clock mode, and randomly in clock mode, it should display an animation. Or, I can throw a sensor on here and say, when I get closer than X feet away from Bender, play an animation or play a sound. So we can also go in here and set the clock. Let's see. So we can choose daylight savings time, time zone, 12 hour, 24 hour, hours and minutes, and so on. We can make the colon blink, or we can turn the animations on or off, and we can exit, and it'll take us right back to the clock. So this is the prototype that allow me to very rapidly build the brain in terms of when should animations happen, why should they happen, what should trigger them, what kind of settings and other features do I have, and at the same time try to solve the problem of what's the exact layout for the grid of LEDs, how's my power distribution on the LEDs, are they too bright, what's that diffuser like, am I using just this simple diffuser, or for example for the mouth, do I need to add a series of diffusers? So just wanted to give a quick update of where I was on the project and where I plan on going, and hoping to rapidly finish this over the next couple of months.